we will be looking at nomenclature and classes of organic compounds. Previously, we've been discussing organic compounds in the previous lectures, and then now we want to look at how are they classified. We want to look at the various classes. We want to look at how they are named, that is nomenclature. All right, so this will give us a better understanding of what organic compounds are and how you can name them. And we would also look at what makes them unsaturated or saturated. But before we start, they are characterized by what we call functional groups. So you need to know this, that all organic compounds possess functional groups, and these functional groups gives you an idea to their reactivity. The functional groups gives you an idea to how you name them. It gives a lot of information about a particular organic compound. So all organic compounds have their various functional groups which we can use and identify them. So, and that is how organic compounds are actually classified. They are classified based on their functional groups, and then we'll be looking at some notable functional groups. You might have been acquainted with some of these functional groups, but we're going to just go through some of the functional groups that are a major in organic chemistry. So let's start with one that is called the amine functional group. So the amines are derived from ammonia. Ammonia is NH3. So how do we get an amine? When the hydrogen has been replaced by one or more carbon. So we have 3 hydrogens in ammonia, right? So as you can see here, so when either of these hydrogen have been replaced by a carbon, of course an alkyl group, we get an amine. So what do we mean? We have nitrogen. Let's replace one of the hydrogens from ammonia by a carbon, and that carbon of course has hydrogen, so it's a methyl group. So we still have the other hydrogen not replaced and the other hydrogen not replaced. So automatically we have an amine. Okay, so and what kind of amine is this? How many alkyl groups do we have here? But before then, let's replace another hydrogen, the second hydrogen, by yet another carbon. So let's have it here. Nitrogen, here is going to be CH3. Here was previously CH3, right? So here's still hydrogen. Can you see that? The same thing we can do, replace the third hydrogen by a carbon, of course the methyl. So we're going to have something like this, H3C, right? So that gives birth to another classification of an amine. Now if you look closely at this first one, okay, we have CH3, and this is the only alkyl group. We'll come to alkyl groups. All right, alkyl groups are groups that has been derived from alkane by the removal of one hydrogen. For example, if we have methane, then CH4, 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 that's methane. When one hydrogen is removed from this, is CH3. We no longer call it methane, we call it methyl. All right, so that is how we derive that. So basically, if you look closely here now, you can see we have only one alkyl group, no alkyl group here, no alkyl group here. So that makes this one a primary amine. All right, so if you look closely to the next one, which you have here, this next one here, how many alkyl groups do we have? We have 1 and 2. So this is called a secondary amine. Then if you look closely to the third one, we have 1, 2, and 3. So this is tertiary amine. Can you see that? So they are all derived from ammonia. All right, by replace one of the hydrogens with a carbon. Okay, so primary amine, how do we name it? Anyways, we'll still go into that. But if you look at the primary amine, it has only one methyl group, so we can call this methyl amine. Going to the secondary amine, how many methyl group? Two of them, so we can say dimethyl amine. Di 2, right? So this tertiary has 3, so we can call it trimethyl amine. So that's basically the functional group, the amine. So you need to know what the amines are. So this is just an introductory. So let's go to the next functional group. So let's look at the alcohols. All right, the alcohols are known as the hydroxyl group. You need to know that the alcohols are also known as the hydroxyl group. Basically, they consist of an oxygen, all right, that is covalently bonded to hydrogen atom. All right, so OH, all right. Basically, we have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So this is what we get to have for an OH, all right. So this is the hydroxyl group, is an alcohol, all right. And usually this oxygen, if for example we have this compound, let's say we have this OH, then we have H here, we have H here, we have H here. So you see, that's OH. This tells you that this compound is an alcohol. And what kind of alcohol it is, you have to check how many carbons. 2 carbons. This is ethane, right, from the alkane series. So we can call this ethanol. We still come to nomenclature, so I'm only giving you an insight on how it's been represented in their structure for a particular compound. So the hydroxyl group can be identified by OH. So the functional group for the alcohols is OH. So, and just like we've talked about in the amines, we can still have primary, secondary, and tertiary alcohols. So I'm just going to use this. Let me see if we can squeeze it in here. If we have carbon with an OH, right? So we have let's say we have another carbon here with H. Then we have let's say we have hydrogen here. Let's say we have CH3 here. Okay, so now this is a different kind of an alcohol. Basically, if you want to know what classification this alcohol falls into, what you have to do is to look at the alkyl group, right? So notwithstanding, this is an alkyl group, if you agree with me, right? And this is another alkyl group. Can you see that? This is CH3, this one too is CH3, but I just wrote it in a different way. So we have CH3, two CH3 group bonded directly to the carbon bearing the OH functional group. You can see both of them are bonded to that carbon bearing the OH functional group. That makes that alcohol to be a secondary alcohol. Can you see that? So now if we have, for example, we have CH3, right? Then we have OH. Then we have H here, we have H here. Then you ask yourself, how many methyl groups are attached directly to this OH? And the only methyl group we can see here is CH3. There is no methyl group here, there is no methyl group here. So we have just one attached to this carbon. Can you see that? So in that case, we can say that this alcohol is a primary alcohol. This is how we identify it. So let's move on. Let's now assume that we have here, let me replace this H here. Let me give another CH3 over here. Can you see? So that means if I'm looking at this new structure right now, I want to show you, you can see we have another CH3 here. How many CH3 bonded to the carbon containing the functional group? So that's what you have to ask yourself. And it's obvious. We have 1, we have 2, we have 3. So that makes this one to be a tertiary alcohol. So this is basically how we differentiate the alcohols too. So you need to know when a compound is an alcohol, an amine, and what kind of amine is it, what kind of an alcohol it is. So that's basically it. Let's move to the next functional group. Carbonyl group. The carbonyl group of organic compounds. The carbonyl group are those ones that contain the carbon double oxygen, carbon oxygen bond double. All right, so basically you can represent them. They have this functional group in them, and we'll look at the aldehydes. We have ones that are called the aldehydes. The aldehydes contain the functional group CHO, right? So, and if you want to represent this, you can say C double bond O and H. Let me make this clearer. So we have H here. Can you see? So we have C double bond OH, and then we have the ketones. They are also carbonyl. They contain the carbonyl group, the ketones. Before that, we are going to have an R here. Okay, so the ketones has RCOR, in the sense that the alkyl group here is different from the alkyl groups here. That's why I used this prime, right? So if I want to represent that, it's going to be R C double bond O with another R. Okay, so this is a ketone and that is an aldehyde. So whenever you see this functional group, you get to should be able to say that, okay, this is an aldehyde and this a ketone. All right, so we'll look at the next one. We have the carboxyl groups. Remember, we've looked at the hydroxyl groups, we looked at the amide group. Then the carboxyl groups, okay, they contain the COO functionality. All right, so one of such is the carboxylic acid. Carboxylic acids. So, and their functional group is COOH. If you want to represent this, it's going to be C double bond. Sorry, so it's going to be C double bond O OH. All right, then we can have an R here. Okay, then we have this residing non-bonding electrons. Okay, so if you want to understand how we came about this electron, this Lewis dot structure, you can check the link to the next video I attach in this video description. That would give you insight to how these dots came about, but this is not what we are looking at now. So this is a carboxyl group, functional group. So we have the carboxylic acid. So wherever you see this, it tells you that this is a carboxylic acid. Okay, one of such is if you have C double bond O OH, probably you have C then H3. Okay, something like this. See, can you see the functional group is there? So, and this is two carbons are there, so this is definitely ethanoic acid. So when we come to nomenclature, all right, we'll get to understand this better. So it's an acid, so this is ethanoic acid. So this is the carboxylic acid functional group. Let's go to the next one, the carboxylic esters. We have the esters. The esters are very much sweet smelling. So we have carboxylic esters. This is how you spell it, not like the ester for a name, okay? So the carboxylic esters are formed when the hydroxy group, we have the hydroxy group, which we've talked about, right? So they are formed when this hydroxy group is replaced by an alkoxy. So alkoxy, we need to know what the alkoxy is, OR, okay? So now, how is that possible? Remember, we had COOH for carboxylic acid. So if you're going to replace OH by an alkoxy is spelled this way, by an alkoxy group, that means we are going to derive what is called an ester. So let me replace that by an alkoxy. Can you see that? So then we can have R, okay? So this is an ester. So if you have structure like this, for example, so this is the functional group. You need to know this functional group. So it could, if you want to expand this, you're going to have R, C, double bond O, O, R. See? So this is an ester functional group. All right. So, and we also have the carboxylic amide. That's another carboxyl group. All right. So we have the carboxyl amide, carboxyl amide. So the carboxyl amide, I don't know if you can see this clearly though. Let me make it CAR. So the carboxyl amide is the functional group where a carbonyl group, you know what a carbonyl group is, right? Is directly attached to what we call nitrogen. All right, when the carbonyl group is directly attached to nitrogen. So basically, we usually have carbonyl group is represented this way. So when it is attached to a nitrogen, and usually here is an alkyl group, all right, and this nitrogen can be attached to other alkyl groups. All right, so this is just what it means. So if we have something like CH3, okay, with the carbonyl group attached to nitrogen, all right, we can actually have here to be CH3 or CH2CH3. Can you see that? So this is an amide. This is an amide because carbonyl group is attached to nitrogen with the alkyl groups. So that makes it an amide. So this is how you identify these functional groups if you come across them. So when we go into nomenclature, which will be in the next clip, you would understand how to name them. So for now, we'll end it here.